The number one differentiator, the number one advantage is that our robots have a vision camera embedded in every arm. It is a smart camera, it has integrated lighting, it's autofocus. We call that eye in hand. It allows us to create a 3D vision calibration using something called a TM landmark. The landmark is designed to be easily detected by the robot's camera and then can provide 3D position calibration. What is traditional? You have to spend a lot of engineering time and dollars. Everything has to be hard fixtured. So you have a machine, it's bolted in, you know exactly where it is. You mount the robot, it's bolted, you know exactly where it is. The workstations, the trays, everything. We have our flexible solution using the TM plus the landmark. This setup eliminates the need for all of that. We automatically alter our program locations based on where we are. So you don't have to be totally fixed. There's a few different buttons right at the end of the arm. One is a free mode. You take the robot by the hand, you move it to wherever you want to program a point, and you just hit the point button. That position in space is recorded right into the program. So AJ's going to go through that. You teach points and then you go into the software, which is really, really cool and easy. And he'll show you how those paths are created from the points that are programmed.
This is the program that's running in here that I'm going to run next for you. So here I'm starting off with display. I'm simply indicating that there's something that the operator needs to do. This is waiting for the operator to do that thing. Here I am indicating that the operator has done that thing. Here's where I go and I take a picture. You'll see the ring light on the robot. It's going to locate that TM landmark, which is connected to my pallet. It's going to move to a point that's above the pallet, and then it's going to indicate here, this is a pallet configuration that I've simply told it I'm just going to use the four corners of the pallet, so I've got just 2 rows and 2 columns. It's going to go to those points. Move is a relative motion, so I've found my actual points by using the pallet node, and then I'm moving relative to that.
One of the other advantages is we can be in collaborative mode and we can be in non-collaborative mode within the same program. That's another differentiator, and that's a plus. So what does that mean? A collaborative robot is slower than a traditional robot. There might be areas in your application where you don't need to be in collaborative mode. You can have the program in a collaborative mode where applicable. You can have certain parts of your application in non-collaborative mode. So let's get into the offerings. The first is called the TM5 series, and there's 2 sizes. There's a 700 millimeter reach and 900 millimeter reach. Now this is a bit of a differentiator. We have heavier payload robots than most of the competition. These are the TM12 and 14s, 1300 millimeter reach and 1100 millimeter reach. So these are much bigger, much heavier payload than a lot of the competition. One of the nice things is there's not a lot of gotchas, little accessories. Everything you see here, you get with the purchase of one robot. Now, we've partnered with Robotique and Shunk, where they have end-of-arm tooling that just plug and play. You have no need to do any wiring, anything like that. So you just actually plug it into the end-of-arm tooling and you're off and running.